Hello and welcome to Shri Tech Education YouTube video channel. In today's lecture, we are going to study what is the gear terminology or terms used in the gears. So let us start. This is the basic diagram to represent the terms used in the gears. We will see each of these representation or term one by one by studying its definition. So let us start. First is pitch circle. Now it is an imaginary circle which by pure rolling action would give the same motion as that of an actual gear. Now it is represented here by this square block I have put there. This dotted line, centrally whatever dotted line is there, this is called as a pitch circle. It is imaginary circle that we are not observing on actual gear, but which by its pure rolling action will give the same motion as that of an actual gear. So this is the pitch circle, and usually all the gears are represented by pitch circles while drawing or while doing any calculation. Therefore pitch circle is very important. Second, pitch circle diameter. Now it is the diameter of the pitch circle. The size of the gear is usually specified by the pitch circle diameter, as I have already told you. It is also known as a pitch diameter. This pitch circle diameter is very important in designing of the gear. So remember this pitch circle diameter. Third, pitch point. Now it is the common point of contact between the two pitch circles. If suppose two gears are meshing, now as represented by this P point, this P point is a point of contact between the two pitch circles of two gears. O1 and O2 are the centers of two gears. Wherever these two pitch circles are meeting, this point are called as a P or a pitch point. Definition is, it is a common point of contact between the two pitch circles. Next, pitch surface. It is the surface of rolling discs which the meshing gears have replaced at the pitch circles. Now observe in this diagram pitch surface element represented by one square block. So that is the pitch surface element which is along the pitch circle but over the tooth surface. So it is the surface of rolling disc which the meshing gears have replaced at the pitch circles. Pitch circle, that is nothing but a pitch surface. Next, pressure angle or angle of obliquity. It is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. It is usually represented by phi, pressure angle phi. So in the diagram, observe that whenever the common normal to the two gear teeth at the point of contact represented by Mn, that is a common normal, Mn, that is tangent to the base circles, it is passing through pitch point P, and a common tangent at pitch point, that is the horizontal line passing through that pitch point, that is common tangent, and the angle between this common normal and common tangent is represented by phi, and it is called as a pressure angle or angle of obliquity. This can be varied, and the standard pressure angle are 14.5 degree and 20 degree. These two pressure angles are standard. It can be vary for different types of gears. Next, addendum. It is the radial distance of tooth from the pitch circle to the top of the tooth. Observe in that diagram, it is represented by a square block. Addendum, it is the radial distance of teeth from the pitch circle to the top of the tooth. That radial distance is known as addendum. Now dedendum, it is the radial distance of the tooth from the pitch circle to the bottom of the tooth. This is called as a dedendum. Next, addendum circle and addendum circle. Addendum circle, it is the circle drawn through the top of the teeth and it is concentric with the pitch circle. Now this addendum circle is drawn from the top of the tooth and it is concentric with pitch circle. Center of pitch circle and addendum circle is same. Next, dedendum circle, it is the circle drawn through the bottom of the teeth, and it is also called as a root circle, also represented by that square block in this diagram, root circle or dedendum circle. Next, one relationship is there between the root circle diameter, that is dedendum circle diameter, and pitch circle diameter, represented here. Root circle diameter is equal to pitch circle diameter into cos phi, where phi is the pressure angle. If you know pitch circle diameter and pressure angle, you can find out the root circle diameter for the gear. Remember this relation for the objective which may be asked in a gate exam. Next, circular pitch. It is the distance measured on the circumference of the pitch circle from the point of one tooth to the corresponding point on the next tooth. Circular pitch represented in this diagram shown by a square block. Observe that distance. It is the distance measured on the circumference of the pitch circle. Now further, here few distances we are going to measure, such as the circular pitch, tooth space, tooth thickness. Observe in that diagram, these horizontal distances shown are measured along the pitch circle. Now this circular pitch is also measured along the pitch circle from the point of one tooth to the corresponding point on the next tooth. It is called as circular pitch. It is usually denoted by PC, P suffix C. Mathematically, that circular pitch can be given as PC is equal to pi d by t. Remember this formula, circular pitch PC is equal to pi into d by t, where capital D is the diameter of pitch circle. We have seen previously pitch circle diameter, and capital T is the number of teeth on the wheel, total number of teeth on the wheel. So this ratio d by t into pi is called as a circular pitch. A later consideration will show that the two gears will mesh together correctly if and only if the two wheels have the same circular pitch. This distance is, if it is same for the two gears, then and then only these two gears will mesh correctly to each other. Now consider, if suppose two gears are having this ratio pi into d by t is same, then and then only these two gears will mesh correctly. Now note that if suppose d1 and d2 are the diameters of two meshing gears and t1 and t2 are the teeth respectively, then for them to mesh correctly, that ratio d1 by d2 should be equal to t1 by t2 to have correct meshing, because pi will get cancelled for these two gears. If circular pitch PC is same, then this ratio must be same, that is d1 upon d2 is equal to t1 upon t2. Remember this also for the calculations and objective asked in exam, gate exam. Next, diametral pitch. Here we have seen circular pitch, now here it is diametral pitch. Now it is the ratio of number of teeth to the pitch circle diameter in millimeters. It is the ratio of number of teeth to the pitch circle diameter in millimeter, that is T by D. Mathematically we are representing it by PD, P suffix D. Diametral pitch is equal to T by D. Now previously, since we are knowing PC is equal to pi D by T, here the ratio is T by D. Therefore we can write relation between the diametral pitch and circular pitch as PD is equal to pi by PC. If you put value of PC is equal to pi D by T, you will get this relation PD is equal to pi by PC. Now next, module is equal to. Now module is the ratio of pitch circle diameter in millimeter to the number of teeth. Mathematically, it is represented by M is equal to D by T. Previously we have seen diametral pitch is the ratio of T by D. Here module is ratio d by t. Now this ratio module is equal to d by t, or it can be said as a reciprocal of this diametral pitch. Exactly module means what? Exactly module is nothing but a how much distance along the circular pitch or pitch circle, how much distance along the pitch circle one tooth has taken for the complete perimeter, perimeter of the gear. From complete perimeter of gear, how much distance one tooth has taken along the pitch circle is nothing but a module, but mathematically it is d by t, pitch circle diameter to the number of teeth. So remember this module, m is equal to d by t. The recommended series for this module by Indian standard is 1, 1.25, 1.5 and so on. These modules are generally used. Next, clearance. It is the radial distance from the top of the tooth to the bottom of the teeth in a meshing gear. A circle passing through this top of the meshing gear is known as a clearance circle. Now there is one clearance distance, and the circle passing through this all clearance distance along the gear's teeth is known as a clearance circle. It is the radial distance from top of the tooth to the bottom of the tooth in a meshing gear, in a meshed gear. This distance is called as clearance, and a circle passing through this top of the meshing gears is known as a clearance circle. This is important if you have to avoid the undercutting of the tooth by another tooth, then clearance is very important. Next, total depth. This clearance is shown here by the square block. Observe that small gap or distance is known as clearance. Next is total depth. Total depth, observe the square block and that distance in that diagram. That distance is called as total depth. It is the radial distance between the addendum and dedendum circle of the gear. It is equal to the sum of addendum and dedendum. Addendum plus dedendum will give you the total depth of this gear. Next, working depth. Now it is the radial distance from the addendum circle to the clearance circle. Working depth is the total distance between the addendum circle to the clearance circle. If you subtract the clearance from addendum plus dedendum will give you the working depth. It is the radial distance from the addendum circle to the clearance circle. It is equal to sum of addendum of the two meshing gears. Working depth. Next, tooth thickness. It is the width of tooth measured along the pitch circle. Yes, I have seen you, or I have told you previously also, circular pitch, tooth thickness and the tooth space. These things are measured along the pitch circle. It is the width of tooth measured along pitch circle is known as tooth thickness. Observe in that diagram. Next, tooth space. It is the width of space between the two adjacent teeth measured along a pitch circle. It is the width of space between the two adjacent teeth measured along the pitch circle. Next, backlash. Now, it is the difference between the tooth space and tooth thickness as measured along the pitch circle. Theoretically, the backlash should be 0, but in actual practice, some backlash must be allowed to prevent the jamming of the teeth due to tooth errors and expansion, external or thermal expansion. Now, if there is no any clearance, then there will be jamming of the tooths due to thermal expansion or some errors while manufacturing. So we are providing some amount of backlash. Theoretically it should be 0, but in actual practice we are providing some amount of backlash, that is the distance or difference between tooth space and tooth thickness that small distance or gap is provided between the two gear teeth of meshing two gear teeth. That is called as a backlash. Remember this also. Next, face of the tooth. It is the surface of the gear tooth above the pitch surface is called as a face of the tooth. Shown by here square block in this figure. Surface above the pitch surface element is called as face, and flank of the tooth, it is the surface of the gear below the pitch surface is called as a flank of the teeth. Top land, it is also shown in this diagram. Top land, it is the surface of the top of the tooth, surface of the top of the gear tooth. Next, face width, it is the width of the gear tooth measured parallel to the axis is called as face width. See in the diagram. Next, profile, it is the curve formed by the face and flank of the tooth is called as a profile. Curve formed by the face and flank of the tooth. Now there are generally two types of gear tooth profiles are available: cycloidal and involute. Each is having its own advantage and disadvantages that we will see in further lectures. What is cycloidal gear tooth profile and involute gear tooth profile. Next, fillet radius. It is the radius that connects the root circle to the profile of the tooth. Fillet radius, it is the radius between this profile and root of this tooth. It is the radius that connects the root circle to the profile of the tooth. It's called as a fillet radius. Next, path of contact. Now it is the path traced by the point of contact of the two teeth from beginning to the end of engagement. Now consider the two gear O1 and O2, it is pinion and wheel, are in mesh. Then the two gear teeth will start the engagement and end the engagement while rotating. Therefore this distance or path traced by the point of contact from the start of engagement to the end of engagement is called as a point of contact. So in this diagram you can observe this point of contact starts at K point and ends at L point. Therefore this distance KL, shown here by one dark line, is called as a KL distance is called as a path of contact. Remember this. Next, length of path of contact. It is the length of common normal cut off by the addendum circles of the wheel and pinion. Now, length of path of contact, if suppose this common normal MN is there in this diagram and it is cut by the addendum circles, where it is cut by the addendum circle at point K, this common normal is cut by the wheel addendum circle, by the pinion addendum circle at point L, that common normal is cut. These 2 points K and L, distance between these 2 points K and L is called as the length of path of contact. Remember this thing, path of contact and length of path of contact. Next, arc of contact. It is the path traced by point on the pitch circle from the beginning to the end of engagement. It is the path traced by the point on the pitch circle from beginning to the end of engagement. Now this path along this common normal MN is called the path of contact, and the path along this curve along pitch circle is called as a arc of contact. Arc of contact. Now arc of contact consists of two parts. First, length of path of contact is also consisting of two parts. This KL distance can be divided into two things, that is KP plus PL, that is length of path of approach and length of path of recess. That is KP distance will be considered as length of path of approach and PL distance can be considered as length of path of recess. Similarly, this arc of contact may also consist of these two parts, that is arc of approach and arc of recess. What is meant by arc of approach? It is the portion of path of contact from the beginning of engagement to the pitch point. So in that diagram, the arc GPH GPH will be considered as arc of contact, and GP can be considered as arc of approach. That means from start of engagement to the point pitch point. This arc is called as an arc of approach, whereas arc of recess, it is a portion of path of contact from the pitch point to the end of engagement of the pair of teeth. Now along the pitch circle, that point is now here H considered H, therefore PH will be the arc of recess, isn't it? And length of path of contact will be KP, length of path of approach will be KP, length of path of recess will be PL, and total KP plus PL can be considered as length of path of contact. So remember these things we are going to revise once again in next video in detail. What is the, we are going to derive these formulas always, length of path of contact, length of arc of contact. But just here now, remember these definitions: length of path of contact, then arc of contact, and one more thing we will define here: the ratio of length of arc of contact to the circular pitch is known as a contact ratio. And contact ratio is important. Significance of this contact ratio is number of pair of teeth in contact. If you find the contact ratio, that means it is the number of pair of teeth in contact. This is known as a contact ratio. So revise this, all the definitions used in the gear or terms used in the gear. These are required for the objectives as well in the exam. These will be the important objective in the gate also for 1 mark question. Thanks for watching the video. Subscribe the channel. Thank you.